So when you hear about machine learning, you hear about what is called supervised learning, unsupervised learning, reinforcement learning, a whole bunch of things. So we'll touch upon a few of them. Supervised learning is the most heavily used. And here is an example. So let us say Thai wants to figure out what size of hall to book, assuming that they have the freedom to book any size hall, right? So let us say that they want to order food. Registration is not an indicator. So what are all the features that they will look at? The person, let's say that they have the record of all the people who attended all the Thai events in the past 4 or 5 years. They must be sitting in some spreadsheets here. You can gather them all together and then you can do some interesting predictions. You can pick the person because the person may come and not come. A person who has registered several times but showed up only 10% of the time happens in meetup.com quite a bit. I'll tell you funny stories about that. So you can find out the person, you can find out the topic. Is the topic of interest to people? Okay. Which topics are more interesting? And so this will help them give recommendation for future topics. Date and time are very important because evening, people, depending on where you are, Saturday morning, 8 o'clock event, not many people will show up. The promotion, of course, is a factor, and the promotion, the timing of the promotion, exactly when you do it. The alignment with business. If you take all the Thai members and all the people who are on Thai mailing list, not necessarily members, and if you know all the businesses that they are in, and if you can figure out all the topics that will be interesting for those businesses, that could be another one. The history of events, like what happened, what happened in the AA events, what happened in fintech events, which ones, in investment events, what are the kinds of things that people are interested in, and then dropout rate. There's always a dropout rate, and it varies. Because suddenly it rains, it's a different dropout rate. And then if Brazil is playing somebody else, then maybe a different dropout rate. Right now, that's more seasonal kind of thing. So let us say that these are called the features in a supervised learning model. So let us say I take all the data from the last 2 years, all the events, and then put all this information. And then I know whether a person attended or not because ultimately they signed. So we have that record. So this is called a label. I can take this entire data and feed it to an algorithm, and I can see if I do a future event on XYZ, on like A for medicine, how many people will attend? Or A for education, how many people will attend? So you can actually do a kind of a prediction and accordingly plan a variety of things. And you can also, from this, you can find out lots of other analytics which may not involve machine learning, like seasonal patterns and what day of the week you get the maximum people and all that sort of stuff. And so this is supervised learning. You give it some data, you give it some labels, the results, end results, the outputs, these are the inputs. And then what the machine does is takes all this data and then it tries to create a pattern. So what you do is you take all the data and you split the data into what is called test data, training data and test data. A simple case is 50% split, but there are more complex algorithms, 70-30 or whatever. You can take this data and give it to the machine and say, hey, go figure out what is the relationship between all these features and my result. And then I can train it with the training data. There are lots of interesting techniques for doing that too. And then the system spits out a model, which is basically an equation. And then I can take this model, and then now I can take the test data. I already know the results. So I'm taking the test data and I'm giving it to this model. And then it should be able to correctly predict, and then I can find out the accuracy of prediction. It's kind of very interesting that you need to kind of randomize the data, otherwise it will do what is called overfitting. That will work with certain data very well, and if you change the data, it will not work very well. But there is also other kinds of things. The data should be clean. There's a whole. And do you know that even though we talk about algorithms and linear algebra and statistics and all that sort of thing in machine learning, 70% of the work in machine learning is data engineering. this feature engineering, data training, and doing all those kinds of things. And that is the, so this is supervised learning, and there are variations, but this is in essence supervised learning. And you could think about this pattern for a lot of other things: customer, product, purchase time, price, promotion, when they bought the product or not. You can use this. So this is a model, it's kind of a template for building supervised learning models for you, and then you can try it out. Yeah, unsupervised learning. I'm going to show you a more detailed version of this. In the case of unsupervised learning, you don't have labels. You have large amounts of data. The biggest problem in data science, machine learning kind of things is getting these labels, correct labels. You learn the topics. So this is a topic discovery. So if you take a huge amount of customer support logs, you analyze them, and you can extract topics, and then you say, wow, there are problems. You know, like if a huge ball of appears about one of your products name keeps on appearing here, you know the moment you look at it, this product has a problem, and I need to think something about it. Right? We need to take and solve it. So we'll come back to this. There is a bunch of techniques, topic extraction, latent semantic analysis, which used to be done slightly before. Now there is something called LDA, which is latent dictionary allocation. Then what is called K-means, which is for clustering. You can dig deep into each one of these things in Google, or if you want to have a technical session, we'll have one. We'll come to deep learning, because this is where we'll spend a little bit more time than the other two. A subfield of machine learning, we already mentioned that, uses artificial neural networks. That is the major difference. All the others use a lot of statistical techniques and all that, and here we use quite a bit of math, but what are called sigmoid functions and a whole bunch of others, but all artificial neural networks. And is inspired by human being. It doesn't mimic human being. Nobody really knows what the human being does. Right now we have this, six blind men, the elephant kind of thing about the brain. The neuroscientists think something else, but we are converging. A simple perceptron. So I will take the same example. I want to go to an event, or my friends attending. Is the topic of interest to me? Okay, is the topic useful for my business? These are the three questions. I simplified it dramatically. And then each one of these questions has an yes or no answer, 1 or 0. It's a binary, right? My friends going, yes or no. Am I interested in this topic? Yes or no. Is this useful for my business? Yes or no. Most of the cases you know. So those are x1, x2, x3. The W1, W2, W3 are weights you associated with this. Okay? So typically you create an equation which is W1 into x1 plus W2 into x2 plus W3 into x3, and you have a threshold value. Unless this value is more than 5, I'm not going to go to the event. That is, and then what you can do is you can adjust these weights. So if the topic is interesting to me, I can adjust the weight to 5, which is what I've done here. So in most of the cases, I'll end up, my chance of going to the event are much, much higher. Right? These weights may be very different for each individual. Each one of us could be running this program. We can choose different weights, and based on that, we said, should we go to this program or not? And basically, Perceptron works like this. It has a binary inputs, it has a binary output. The output is yes or no. You're going to each one of these x1, x2, x3, they're fairly well known. And this is the thing. And the threshold is the one that decides above 5 only I'm going to go. Right? I can set the threshold to 3, in which case I'll go to most of the events. I can set this threshold to 7, in which case I may not go to a lot of these events. So that depends on your individual thing, and you adjust this whole stuff. There is a fundamental principle behind this. Okay? The problem with this is called the Perceptron, and this is again some 60 years old concept. It languished for a long time without anybody really worrying about it. Redrawing of the diagram in slightly more fancy colors. These are called inputs. Then you have weights associated with each input. Then you have this summation and bias. That can be, right now it's a simple summation, but you have more sophisticated functions. One is called sigmoid function, which is being used currently quite a bit. and then activation, saying that, hey, if these things trigger, will I take action or not? And the output is true or false. Okay? We saw a single layer perceptron, came to multi-layer perceptron, where you have a bunch of inputs. This is called the hidden layer. Then you have the output layer. What happens is, in all these, the AlphaGo kind of systems and the DeepMind, there are a whole bunch of those kinds of things where object recognition systems, and I think Microsoft has one deep learning system with about 17 layers. When you say deep, it's not like the depth of knowledge. It is actually how many layers that are there. So I don't know how they got the name deep there, but it is how many layers are there. So essentially, think about it this way. We saw a simple perceptron, how it works. Weights, inputs, and a threshold, which is the bias. You can play around with it, and then an output. So each layer takes a low-level inputs and provides high-level outputs. And the next layer takes the high-level outputs and provides even higher-level outputs. And that is how, when you recognize a picture, you start with pixels, you find edges, and from edges you start finding shapes, and then from shapes you start finding actual figures. So is there a cat in the picture? A simple answer. And how does that happen? You run all the input, which is each pixel is an input. You actually vectorize the stuff and give it input. And then this is supervised learning again. You know the cat is in the picture. So you will say, if it says cat is in the picture, I said, great, leave it alone. If it says cat is not there in the picture, go back and adjust the weights. So the way neural networks work and the way you keep on weighing based on the output, and since you know the output is true or false, you go back and adjust the weights, and then these are called tuning the hyperparameters or whatever, and then that is how you achieve. So you show millions of pictures, and then start recognizing various objects, and the output need not be one, it could be multiple. Like the next one. This is a artificial neural network for digit recognition. It has bunch of inputs, basically 784 inputs. So they take a pixel image 28 by 28, which comes with 784. They feed it to a hidden layer, and it's not as if each neuron is connected to multiple ones. It's each neuron provides multiple outputs. This graphic basically shows they're connected to all other neurons. So everything is interconnected. It's as messy as the brain in some ways, and then exactly 10 outputs. So what you do is you show it 7. See where that 7 lights up. If it doesn't light up, go back and adjust the parameters. You play around with the weights, and somehow you can make 7 appear. Same thing you do with 1, 2, 3, 4, 5, 6. And that is basically, this is about 74 lines of code. You can actually write a handwritten digit recognition. And it's that simple. And that's essentially what the nice thing about this neural network is. I mean, once you take the artificial neural networks, several other versions have come. This one, the ones that recognize objects, are called convolutional neural networks, and they have some very interesting techniques for doing it. We're not getting into any of those things in depth, but the power of interconnecting pieces of information and then moving them to higher levels of output is essentially how this whole thing works. So there is a database called MNIST. NIST is an organization in the US, I think National Institute of Software Technology, but I may be wrong. They have large amounts of data. They took a lot of handwritten data from a variety of, from students, from people, all kinds of things, and they have images. They have about some 60,000 images that was used as a training data for recognizing, and right now they're pretty good. And they've been working for a long time. A test. Not another sentence. This is definitely a test. You want some minutes.
Again.
Oh, since he can't see it on his screen.
Yeah.
89% similarity of these two sentences. Now you type, this is not a test. Just delete surely and then replace it by not. Okay. I would not say this is a test and this is not a test or similar, but they kind of think about it in some way. They're not, they are kind of similar, right? So can you go back to the slides? I have a whole bunch. I'm sorry, I'm going to make you do a lot of work. So I tried with all this. This is a test, this is definitely a test, this is not a test. This can be a test, but we are not sure. Let's just, can you copy paste it? That way at least save you some. This can be a test, but we are not sure, this one. So I tried interesting variations of this. So the way, this is called a similarity measure. Actually, to be geeky, it is called a cosine similarity measure. So what we do is, this is the new power that we are like heady with it. You can take words and vectorize them. What does it mean? What you can do is, you can take words and you take a vocabulary where the words occur. Let's say your vocabulary is 10,000 terms. Every word in your vocabulary has a bit allocated to it. So given a word, you get a bit vector. Okay? Along 10,000, column bit vector. So you take this vocabulary and then you try, there's a library routine called vectorizer. You can simply give it, pass it a sentence, it will return you a vector. And then we do these vectors, simple vector arithmetic, right? In this particular case, cosine is, if cos 90, cos 0 is 1. Right? That's my trigonometry. Okay, cosine similarity means that both vectors are overlapping with each other or touching each other, exactly aligned with each other. If they are far distance, you will get a slightly different measure. So you will get 100% if they're, let's go back there and just type exactly the same sentence. So this is, what is the big deal here, right? We can do a string comparison, we can find out what it is. But let us, you can go to the next slide. Oh, sorry. So, similarity measures. So what is the big deal? I mean, we're taking two sentences, I'm telling you how similar they are. So what am I going to do with it? First thing is question similarity. People are asking you questions by email. Okay. If this question has already been asked before, how do you compare? One thing is you can case fold it so that uppercase, lowercase, there is no difference. You can compare strings, but that is the old method and the strings cannot compare. Because the way I type this is a test, and this may be a test, this could be a test, this will be a test. Any of those kinds of things are very different from what others do. So the longer questions, we should actually play around with this. I'll give you the URLs for this, you can play around with this. Longer questions become more complex, right? So how are you going to, what happens if one word is missing in between? How do you compare? Do you like keep aligning, skip it and align it and all that? None of that. It turns out beautiful math really, really helps. What you do is you turn this sentence into a vector. So there is a paper, I think 2015 written called Word to Vec, which word, the whole space is called embeddings, word embeddings. And this has like revolutionized the way you can play around with this. So here are a few examples. Question similarity, I can find out. If they are very similar questions or 90% same, I can direct them to the same answer if it's a support question, right? Answer similarity. If two guys copied each other, of course, if they're exactly the same, but they'll be smart and they'll change a few words here and there. So if they're 97% similarity and they're sitting right next to each other, they definitely copied or whatever. So the answer similarity is also kind of interesting, right? Problem issue similarity for support, I think it's the same as question similarity. What I had in mind with question similarity was frequently asked questions. So every website has a list of frequently asked questions. If people type this, they will go to the question and they'll take out the answer and display the answer. What happens if they don't exactly ask the question? Maybe right now what is the technique being used? You use keywords to match and then get it. Sometimes you do get it. And not only that, now Microsoft will come and say, are you happy with the answer? And of course, no, I'm not happy. Because he didn't answer my question, right? So can you solve that problem? Even designing frequently asked questions, can you come up with generation, which is, we'll come to it in a little bit, natural language generation. Can I generate different kinds of sentences for the same, with the same semantics or same meaning? So content similarity. Somebody wrapped the content on your website, or somebody copied, or somebody quoted your content. You can find out pieces of content. These are all, of arbitrary length content. I'm not talking about like simple one sentence. News headline similarity. You saw the picture. I'll come back to that. We'll run. That is the next demo that we're going to run. The topic similarity. So like several news items cover the same news, and you can bring in by just looking at the headline similarity. You can come back, and they may not contain exactly the same words, and still I can come back and say these are very similar, and they're using for clustering. Economist uses it, and a whole bunch of New York Times uses it. And many of those kinds of people use the clustering, and Google uses it. So you can actually write a Google News kind of. You just get an RSS feed of all the questions, and you can cluster them and do that. Okay, clustering news items. Can you? So this is not, we didn't write this. England, your favorite topic is. There used to be a huge ball of Trump. Fortunately, it's gone off the edge. It's not there anymore. What is happening here? So look at all this. You click on any of them. Pick any and click. These are all the news items. So what this whole source code is available freely. So you can take it and play around with it, and if you want to experiment with it, you come to one of our Build to Learn sessions, and we will help you. So there are news items. So what is that? This is like Russia today, North Korea sanctions. There's a whole bunch of things. Oh, okay, Korea, because of Korea. So there are all these. What they do is they take a random, all these streams of news, then they cluster it. Imagine this is my newspaper. Every morning I get up and I see this bunch of bubbles, and I put a filter saying that minus politics or minus soccer. If you want, or plus soccer, depending on what you want. Now you got a new set of bubbles. You know which are the trending stories, and you just look at them. It's just a new visual interface, but it comes out of the same basic data that we all get. Take all the 10 English newspapers in India, bring them all together. They all have what are called RSS feeds. You can get all the news items, headlines, and the first paragraphs, and you can give it to this algorithm, and you can get these bubbles for doing it. This one, I think also we have to tap. This one is kind of an interesting one. And this is the last of the demos. You can just type some. Anybody wants to suggest? I will be stage demos. You want to just give a sentence that assume that you're calling tech support, some company, and you want to say something. Anybody wants to volunteer? That is tech support question. Okay, who is doing tomorrow? So this is not that great of a product, but what they do is...
That's something they're saying I wasn't a smart question.
No, that's not. No, what I'm saying is that I was playing around with it, it comes back with query most of the time. But pick some others, So what it does is, and I'll tell you exactly what it does and why it is useful. Thanks anything, use your imagination. It is now.
Yeah.
Okay. This extracts intents. So when somebody types you something, you pause it. They have an API. They have very good pricing. I don't sell this product. I don't own it or anything like that. But you can call the API and send these text strings, and it will return the intent for you. And then it will say it's news, query, marketing, spam. Lots of them, it's okay with spam. So what happens in this is intent extraction is essential if you're going to have chatbots on your system. So you want to know what the user is asking for so that you can give the proper answer. So what do you do when, like, two things later, of course you take the majority one and say, do you mean blah, that kind of thing, and what is this? Germany, so you can actually start taking them and start using them. In the case of chatbots, the intent analysis is very important because you want to understand what the user is saying. But this, standalone intent analysis is not enough. You also need what is called context. So in the context, so when you have conflicts, whether it's news or whatever spam, you can figure out what it is based on what you're talking about. So intent extraction analysis, understand intent from user, questions and statements. Again, support. Everything goes back to when people come and type a question. So some chatbot pops up and says, hi, can I help you? And then you try to type some question. And then you want to send it off to the human, to somebody chat, right? Or if the chatbot can keep up the answer for some time, you can do that. So this is the input analysis for chatbot, the customer support interactions, and you can also find the latent intent. Sometimes people saying something may not exactly, you can't just take the fact and just interpret it that way. Then you can do a lot of semantic analysis where the words may not be exactly the same. Some of these word vector things, with even substituted words, or what they do is something very interesting. They find these co-occurrence patterns. So you all use cell phones, right? And you use this when typing, it predicts what is the next word. Right? Simple Markov chain is based on kind of thing and all that. So the predictive text, they know typically if you type this word, chances are that this is going to be the next word. Okay. I don't. When I say mean may appear, I don't mean to say this. But what is interesting, I noticed in these little machines, in the predictive analytics, is that they actually customize it based on what you typed. So they also take your input that you have typed and then they customize it, very personalize it for you. And I don't know whether you noticed it or not, and that starts happening fairly quickly. Sentiment analysis is very interesting. Yesterday I was having a conversation with a company. They said that they sell some equipment for bikes and they're getting a lot of feedback through the Zendesk and all that, and they're doing some sentiment analysis, everything controlled. Suddenly all their users went and started a Facebook group, and then they're discussing all kinds of things. And these people have no control over exactly what is happening. They can't. They are not the admin for the Facebook group. They can't even shut anybody down. So they don't know which ones to pay attention to because there are about 100 messages every day. No human being can sit down and read it. So the reason I got called was somebody called me and said, hey, can you help these guys? Can you figure out what to do? And we went and looked around, and there are a couple of sentiment analysis packages from Amazon and Google that you can actually use the APIs and do that. They'll say positive, negative, neutral, mixed sentiment kind of thing. But my question was, hey, knowing that is good, but don't you want to go, if it is negative, do you want to go to the depth and see what is the depth of discussions and see what is, because the sentiment analysis ones will take the top level news items or top level discussion items. They don't go into the reply patterns that are there below this. So can you, and what is the context for this dissatisfaction? Is it related to a certain product? Don't you want all these things popping up in your dashboard? So this analysis was very difficult to do before with human logs, somebody typing in there in Salesforce. That's why Salesforce bought one of the biggest AI companies. In fact, now a lot of them, they're spending, I think I mentioned it in my previous talk, about 450 or to 500 people are there in Salesforce data science team. Because their market intelligence, sales intelligence, all of them, they're trying to analyze all these logs. That is the end of it.